everyone, my name is Knapsack and my topic for today is all about the knapsack problem. So what is knapsack problem? So knapsack problem is a given set of items, each with a weight and value. Determine the number of items to include in the collection so that the total weight is less than or equal to a given limit and the total value is as large as possible. So let's start. We will first look at the problem of what exactly in the knapsack problem. So given a set of items, each weight and value, determine of item to include the collection so that the total weight is less than or equal to a given limit and the total value is as large as possible. So what we are expected to do is, we will be given a set of items. Each item will be associated with the weight and the value. So assuming we have the sack and we have to fill that sack with items. However, the capacity of the sack is limited. So what we are supposed to do is, we have to try to maximize the profit by filling in as many items as possible. So first, we will just locate how to solve it. We will be doing it using the greedy strategy in this video. And since it is the 0-1 knapsack problem, we have to keep in mind that we can break on items into 10 parts. Either we take these items or we don't take it. So consider problem given to us. So here, we have 3 items. So we have set the value of n is equal to 3. And m is 20, wherein the capacity of the knapsack. There are 3 items. So we will see for the first item. The profit is 24 and the weight is 18. For the second item, the profit is 25 and the weight is 16. And the third item, the profit is 15 and the weight is 20. List down the items. For each item, we have the profit weight written. So find out P divided by W. So here, I have find out the values. So for the first item, the profit by weight ratios is 1.33. For the second one is 1.66. And for the third one is 0.75. Once we have found the profit by weight ratios, the second step is to arrange the values. And we have to arrange it by decreasing order, which means we have to do it in the arranging into the descending order. So now, from these listed values, we can see that 1.66 is the greatest one, and then after that, we're gonna have 1.33, and then the last will be 0.75. So, if we consider the corresponding items, I2 will be listed first, followed by I1, and then I3. We listed down the items which is I2, I1, and I3. So this is the second step. Once this is done, we can start filling up the knapsack. So here initially, we have initialized some variables to 0. This is SW is the weight of the sack. SP is the profit of the sack. So initially, we haven't added any items yet. So the profit is also 0 because we haven't added profits yet. And since the sack is empty, we have an empty set. And M is the capacity of the knapsack. So we can start now based on this order of items. we have keep adding the items. So, is W current weight is the sack. Initially, we will be adding I2, so the total weight will be 0, which is the current weight plus the item that we are adding, which is 15 for I2. And since we added these items accordingly, we will have to increase the profit as well. So, SP is the current profit plus the profit of the item that we have selected, which is 25. So, the total is 25. So, now we have the weight of the sack, which is 15, and the profit that we have attained so far is 25. However, the capacity of the knapsack is 20. So we still have a space in the knapsack. So add more items. So we can consider the next item I1. For the item I1, the weight is 18. And the current weight of the sack, which is 15, will give us 33. However, 33 is greater than the capacity of the knapsack. We can't add it to the sack. Hence, we are going to select item 1. So our final solution would be weight as 15 and the profit is 25. Since it's the 0-1 knapsack problem, we can break an item into different parts and add a part of an item. So this would be our final solution.